Hello, welcome. Let me explain how to calculate the vectors from its components and how to calculate the components from a vector, given vector. Okay, so again, we learned that vectors have both magnitude and direction, right? So a vector would look something like this. So this is the coordinate axis, and you draw a vector that has magnitude, which is the length of the arrow. Let's say that's the arrow, and let's say this is vector A, like that. So this arrow means that this A is a vector. It could have a magnitude, it could be like a force or a velocity. So let's say A, the magnitude is 10 Newton. That's how much force you apply. And the angle right here, let's suppose this is about 30 degrees. This is the angle. So this is called a full vector. So that's vector A. It is written as AX in X direction plus AY in Y direction. And we can calculate how much it is in X and how much it is in Y. So these are called the components of the vector. So the components would be, so X component would be how much it is in X. So this would be AX. And how much it is in Y, so that much, that's AY. Okay, when you look at this, because AX is right next to the angle, this is called the adjacent component. Okay, so AX, in this case, it is the adjacent because it's right next to the angle. This is the opposite because it's directly opposite of the angle, so that's the opposite. This one and this one is the same. So we have AX and AY, and we can calculate exactly what the value of AX is and what the value of AY is. And these are the components, okay? So for this one, because this is the adjacent, so what I do is I write adjacent as cosine of that angle, and opposite as sine of that angle. Okay, so this works all the time. So if I do X component, then I can write AX is equal to A cosine angle. So A cosine theta, theta is 30 degrees in this case. So I can write 10 Newton times cosine 30 degrees. Okay, so that's what the X component is. And you can use calculator to calculate cosine 30 and write the answer. Similarly, AY is just the Y component, which is the opposite. And again, opposite is sine. So I would write 10 Newton times sine of 30 degrees. And this is sine 30 is 0.5, so I don't need to use a calculator. And 0.5 times 10 is going to give you 5 Newton. So I know the magnitude of this. Let me just quickly calculate cosine 30. So cosine 30 is 0.866 times 10 gives you 8.66 Newton. So let me write that, 8.66 Newton. So I have AX and AY. It's that simple. Okay, so this is how you calculate all of the components for any kind of vector that is given. Okay, it is also possible to calculate this full vector and the angle by just looking at the component. So let's suppose we were only given given AX and AY, right? So only this was given and this was given. Just based on that, we should be able to calculate the length or the full vector and the angle. Okay, so let's try to do that. So either you should be given the full vector and the angle, and you can calculate the components. But if only the components were given, you should be able to calculate the total vector and the angle. This is how it's done. So to get the total vector, in this case, you know the answer. It should be 10. Okay, let's try. So the resultant vector or the total vector A would be equal to square root of ax squared plus ay squared, and that's what the equation is. Ay squared, all I have to do is just square root of 8.66 squared plus 5 squared, and that should give you total should be 100 inside this square root, and you get 10 Newton. So I just used the components and got back the full vector. How do you find the angle, this angle? Again, you can calculate that angle using the tangent. So theta, the angle, is equal to tangent inverse the y component over x component. So ay over ax gives you the angle, so that's equal to tangent inverse of y is 5 divided by x is 8.66, and that should give you 30 degrees. You can use the calculator and you must get 30 degrees. Okay, so if you use degrees. So this is how you handle all of the components. Sometimes this vector could be here, oriented this way, or here, or here. You should be able to calculate the components, or if the components are given, you should be able to calculate the full vector. You can also add two vectors. So if you're given A there and then B here, let's say, then all you have to do is just calculate x component of A, x component of B, and just use all the x components together. And do the same thing for y. Add y component of A and y component of B, and add the components. And then just to get the full vector, you're going to have to write the sum of x component squared plus sum of y component squared would give you the total resultant of that vector. Okay, so let me do a problem. This is problem 141, and a lot of you actually asked me a question about this 141. It has three vectors. So this is just the coordinate axis, and it has three vectors. One vector pointing in 37 degrees from y-axis, like this, and it is 37 degrees, and that's 12 meters. That's vector A. It's a vector, but it's in meters, so 12 meters. Okay, that's given. The other vector, vector B, is 40 degrees below. So B is 40 degrees below, and it's 15, so should be slightly bigger than 12. So I think that should be good enough. So that's 15. So B is 15 meters. And we have one more vector, and that's vector C. And let's see, C is 60 degrees from x-axis. So maybe something like this. Let me use slightly different color. And that's only 6 meters, so half of this. Okay, so 6 meters, and that's C. And it is at 60 degrees here. So that's 60 degrees, and this one is 40 degrees. Okay, so this is 40 degrees. So this problem asks, compute the x and y components of vectors A, B, C, and actually it just says calculate the components, that's all. But you can also calculate the sum of all of these vectors, okay, and also calculate the direction of the resultant. So let me do that, and I will start with A. So I want to calculate the components of A, AX and AY. So let me write X component on this side and Y component on this side. So let me write AX right there. So AX equal to, X component, again, I write X component is here, right? This right here, okay? That's the X component right here, okay? But this is opposite to this angle, Okay, so x component, but it's opposite. When you bring this pen to x-axis like this, you're moving away from this angle, so it's in the opposite side of the angle. So I need to write sine of 37. Okay, or you can also do cosine, but cosine of this angle right here, which is 90 minus 37, and it will give you the same answer as well, 53, right? Cosine 53 would give you the same thing as sine 37. So I'm going to write a sine 37 because the given angle, I move away from this, so that's the opposite side, and that's why it's sine. Even if it is x component, it is sine because I'm moving away from the angle. Now y component would be cosine because it's the adjacent side. So the y component, y is along this, and x is along this. So y is, you can write ay equal to a cosine 37. Okay, so that's all. That's the x component and y component. Okay, so let's go to b. So for b, I'm going to write bx equal to, so again, put the pen, that's the direction, the tip is the direction, and then I have to get the x component, I have to bring the vector here along x, and the distance from here to there, that's what the x-axis, x component would be. So that would be 15 meters, or b, right? Sine or cosine to bring it here. It's the adjacent side. This is the adjacent, so I'm trying to find the component right here, right next to the angle. So that's the adjacent, so that's cosine. Cosine of 40 degrees. And by would be, I bring this vector here, and so downward. So that means I have negative sign because it's pointing downward to the negative y direction. So I write b, and that's sine because that's the opposite side of 40. Okay, so let's do the last vector, which is c. So cx equal to, so x component, so I have to bring this here, so that's the adjacent component. So cx is c times cosine 60, but this is pointing in the negative direction, so I have to write the negative sign there. Okay, like that. cy is opposite side, but it's downward, so cy would be minus c, which is 6 meters, times sine of 60 degrees. So these are the x and y component for all three vectors. You just put the number, a is 12, b is 15, c is 6, and then just calculate and you'll get the answer. Now if you want to get the resultant, what do? You just add all of these numbers. That would give you rx, and you add all of these numbers, that will give you ry, right? So that's the x component, sum of all the x components, sum of all the y components. All you have to do is to get the resultant, r equal to square root of rx squared plus ry squared, and that's going to give you the overall vector, the value of vector. Okay, and the angle, tangent inverse, so theta would be tangent inverse of ry over rx, and this is going to give you the answer. So I guess you can just put the numbers and get the result, and that's all. So if you know how to do these, you should be fine. You should be able to calculate components or the angle or the resultant of any combination of vectors. All right, so practice a little bit more, and I think it will be you'll get better. Okay, all right.